remaining topics. So before go to the topics, what we discussed yesterday, so regarding on corrosion and its types, the destruction or deterioration of metals by environment through chemical or electrochemical changes due to the continuous reaction with the environment, we call it as a corrosion. So in the types are uh, regarding on first one is differential metal corrosion, second one is differential aeration corrosion. So remaining types are also there, but university has mentioned these two types only. So in the differential aeration corrosion, waterline corrosion and pitting corrosion is also there. So these are the types of the corrosion we have explained. I think you are also learned. Next, the same way we can continue to that. If it is, it will react with the atmosphere, react with the environment due to the presence of some gases. If no gases, no corrosion. No humidity, no corrosion. So far, some of the factors influence the rate of corrosion. So in those factors, we can broadly classified into primary factors and secondary factors. So out of those, these primary factors are related to the nature of the metal. So in that word, nature of the metal in terms, it is electrode potential. The more different electrode potential metals we have selected for construction, the devices or instrument designing, more rate of corrosion is more. So we have selected less potential difference or corrosion difference or open potential difference. The rate of corrosion is less. So that is the nature of the metal. So followed by this, we can next point is regarding on uh, anodic and cathodic area. So coating of anode with ಹೇಳ ಕಾಣಿಸ್ತಾ ಇಲ್ಲ ಡಿಸ್ಪ್ಲೇ ಬರ್ತಾ ಇಲ್ವಾ ಆಯ್ತಪ್ಪ ಏನೋ ಒಂದು ನಿಮಿಷಕ್ಕೆ ಏನಾಯ್ತಲ್ಲ ಇದು ಹ್ಮ್ ಬರ್ತಾ ಕಾಣಿಸ್ತಾ ಇಲ್ವಾ ಸರಿ ಸರಿ ಇನ್ನೊಂದ್ಸಲಿ ಬ್ಯಾಕ್ ಹೋಗ್ಬಿಟ್ಟು ಟ್ರೈ ಮಾಡಿ ಈಗ ಬಂತಾ ಚೆಕ್ ಮಾಡಿ ಹ್ಮ್ ನೋಡ್ರಿ ಸ್ವಲ್ಪ ಹೊತ್ತಾಯ್ತಲ್ಲ 5 ನಿಮಿಷ ಆಯ್ತಲೇ ಶೇರಿಂಗ್ ನಿಂತೋಗ್ಬಿಡ್ತು
Hello, Sumit. I'm audible, Sumit. Okay.
ಈಗ ಬಂತಾ ಹೊರಗಡೆ ಬರ್ಲಿಲ್ವಾ ಏನು ಮತ್ತೆ ಓಪನ್ ಮಾಡೋದನ್ನು ಬರ್ತಾ ಇಲ್ಲ ಸ್ಕ್ರೀನ್ ಶೇರ್ ಆಯ್ತು
ಆಗ್ತಾ ಇದೆ
ಕಾಣ್ತಾ ಇಲ್ಲ ಅಂತ
ಅವ್ರ ನೆಟ್ವರ್ಕ್ ಪ್ರಾಬ್ಲಮ್ ಸ್ಲೋ ಆಗುತ್ತೆ ಬರುತ್ತೆ
ಬರ್ಬೋದು ನೋಡ ಇಲ್ಲಾಂದ್ರೆ ನೋಟ್ಸ್ ಅಲ್ಲಿ ಯು ಕ್ಯಾನ್ ಫಾಲೋ ದಿ ನೋಟ್ಸ್ ಓಕೆ ಲೆಟ್ ವಿ ಸಿ ಬಂತಾ ಓಕೆ ಓಕೆ ಥ್ಯಾಂಕ್ ಯು ಸೊ ಅದು ಕಾಣಿಸ್ತಿಲ್ಲ ಅಂದ್ರೆ ಹಂಗೇನೆ ನೋಡೋಣ ನೋಟ್ಸ್ ಕೊಡ್ತೀವಲ್ಲ ಅದು ಫಾಲೋ ಮಾಡ್ಕೊಳ್ಳಿ ಯು ಹ್ಯಾವ್ ಟು ಫಾಲೋ ದಿ ನೋಟ್ಸ್ ವಾಟ್ ಐ ಹ್ಯಾವ್ ಗಿವನ್ ಸೊ ಇನ್ ದಟ್ ಓಕೆ so in this regarding on the types of corrosion, then types of factors Those are two types. First one is uh, nature of the metal. Second one is regarding on environmental factors. In first, the anodic and cathodic area. So coating of anode metal. Next is the coating metal is acting as anode, not affected. The coating of metal, coating metal is cathode, base metal is anode. Any small pinhole is there due to the less percentages of anode, more percentages of cathode, severe corrosion takes place. That is one point. So avoid to coating of cathode metals to the base metal. Third point is nature of corrosion product is the stoichiometric, non-porous, highly insoluble, and low ionic and metallic conductivity. So this stoichiometry branch of chemistry related to the volumetric and gravimetric masses with related to the, its molecular mass. If it is, for example, in that 2 or ml, 3 ml of standard solution, afterwards it is related to its molecular weight. So that is we can call it as a stoichiometry. If it is not related, we can call it as a non-stoichiometric. In that non-stoichiometric, instead of 2 ml of using the standard solution, it will take 12 ml, 20 ml. It's unrelated totally. So that is non-stoichiometric. There is highly insoluble. What the small thin layer scale has formed on the metal, afterwards it should not dissolve. Should not dissolve. That itself is protect the base metal against the corrosion, against the further corrosion. It will protect it. So that is we can call it as a highly insoluble. The third point is I can call it as a non-porous. What is the coated metal or anodizing or in a small scale? No porous. If porous is there, it can automatically dissolve. And that should be that region wherever the corroded part is having this less conductivity of ions. So for these nature we can call it as nature of corrosion product. So all these metals of aluminum, titanium, chromium, all these metals, they can do it. Other metals are not possible to do it. Some of its nature of the metals characters. So non-stoichiometric, highly soluble and highly porous, including of high conductivity, ionic conductivity. That is the nature of the corrosion products differences. So this is more corrosion takes place. These are related to the primary factors. As the same way, to pass on to the secondary factors, that is pH, temperature, and conductivity. So, in this pH, temperature, and conductivity, if it is increasing the pH, the hydroxides has formed. So, that is basic alkaline solutions has formed. Those hydroxides scale will give stability or resist against the corrosion of further. So for hydroxides layer also acting as some of the metal thin scales, so that is protecting. Increasing the pH, decreasing the rate of corrosion. Decreasing the pH, increasing the rate of corrosion because hydrogen is released at the its cathode. So next is temperature. While increasing the temperature, rate of corrosion is more. Decreasing the temperature, rate of corrosion is less because the conductivity of metals are more while increasing the temperature. While decreasing, it will conductivity is less. So optimum temperature is better to us for reducing the rate of corrosion. As the same way, the third point in the environmental points are secondary nature of the points, that is conductivity. So this conductivity means if we are using some pipes are submerged in the underground due to supplying of gases, due to supplying of water. So in that water we will use to possible to pumping of sweet water. The ions are very less. the rate of corrosions are very less. Suppose if you want to ಮಾಡ್ತೀನಿ ಸರ್ ಆಮೇಲೆ ಫೋನ್ ಬಂದು ಮಾಡ್ತೀನಿ ಸರ್ ಫೋನ್. So in that, the if you want to pump the salt water, if you want to pump the salt water, the ions are more. Immediately the pipe should be conduct the corrosion because of its the ions are there in the water. So far, so better way is the less ionic conduction, less metallic conduction is passed. As the same way, at the time of burying the grounds, the pipes in the grounds, so we can what we can do it is the lodging with sandy soil compared to the loamy or any other types of the soils, because these sandy soils having the less ions compared to the loamy and clay soils. Clay soils having more ions, so rate of corrosion should be more if we covered the any of the metal pipes in the underground systems by clay soils more conductive. So far, all these precautions we have taken, that should be coating, that should be reducing the rate of corrosions. Of course, so next is the regarding on we will going to discuss on the protection of corrosion. So the protection of the corrosion, first one is metal coating, second one is the say inorganic coatings also, third one is organic coatings. So out of these, the metal coatings are, if you would like to anodic metal to the base also we will coat. Cathodic metal to the we will coat to the base also we will do it. Both the types of metals we can do it, but the more useful to us is only the anodic metal, because the anodic metal is coating to the base metal. At the time base metal acted as cathode, base metal acted as cathode, so then the anodic metal is feeling or suffering from corrosion, the cathodic metal or to be coated metal is not affected by any corrosion. So far, the better way is coating of anodic metal to the base metal made as cathode. It is a good mannerism and good useful to the us also. It is a good investment, no problem. So as the same it is reverse manner. If we coating of cathodic metal, if we coating of tin on the iron, any small mistake of when pin hole is there not coated of any one minute point is there not coated by tin, immediately the less of anodic area and more of cathodic area, severe corrosion takes place. So far, better way is only the coating of anodic metal, the make the base metal cathode, that is a very good mannerism of coating metals. In that example is a galvanizing or galvanization. What is this? The coating of zinc on the iron is we can call it as galvanization. The process is galvanization. The coated metal is a galvanized metal. So for in this, what we are doing is first of all pre-treated of metal by mechanical pretreating, flame test also. So along with this, using of any emery sheets, any of the impurities supposed to be pasted is there, or it is coated, or it is sticked on the outer surface, that should be very neatly removed. After that, pre-treated metal is then subjected to dipped into the organic solutions. That is, we can call it as a degreasing. So dipped into the organic solvent, we call it as a degreasing. After that process is taken out and dipped into the dilute H2SO4, we can call it as a pickling. So we can call it as pickling. So followed by, if it is any still in many minute impurities are not fusible form, not dissolved form is there. That type of the compound has not formed. So for that type of, we can dip it into the flux. Here the flux plus gangs you can react with, made into this slag. So in that zinc chloride and ammonium chloride is we can molten. So dipped into that already pre-treated metal of degreased and mm, metal is dipped, any minute, any very very minute or 0.001 rpb or even it is a parts per million pm is there, that is also the minute of impurities made into the fusible one. It is now it is completely free, its surface is free from all impurities, all anything dust is we can remove. Then it is dipped into the molten zinc that should be coated. So we can measure how much of this thickness. If you want 1 millimeter or 0.1 millimeter, 2 millimeter. So based on this, the wheels, the we can fix it, and excess of zinc will be removed. The excess zinc is collected in the container. Then it is again it is back to the molten zinc at a time. So it's maximum 400 degree temperature enough to this molten zinc, but that temperature should not be affect to the base metal. So it is we can call it as a hot dipping method. Hot dipping method. So then it is that metal is we can call it as a galvanized metal, and the process is we can call it as a galvanization. So excess of the zinc should be removed from this the removing wheels, that wheels we can remove. So this is we can call it as a explain the process of galvanization of iron. As the same way was tinning is also there. Now it is not in the syllabus. You don't worry about that. So next thing is this coating of metal. So next is the anodizing. So some of the metals, what we can characterize aluminum, titanium, manganese, tantalum, zirconium, molybdenum, including of tungsten. So some of the metals, after they have formed the react with the components of the air, that is dry corrosion, forming a thin layer or any patches on the metal, so that patches will support, will resist to the further corrosion of the metal. So will resist to the further corrosion. So for those type of the metals are suitable for this the process of anodizing. So anodizing look like you will take one beaker containing of electrolytes. So followed by, so you can take two metals. One is to be coated, another one is coating metals. The to be coated, you can make it as a cathode, that is a steel. So followed by you can the coating of aluminum or coating of silver or coating of yeah, one good. So coating of anything, so make it as anode connected to the battery. Anode is connected to the anodic electrode of battery, and cathode is connected to the cathode of battery. That is to be coated, make it as a cathode, no problem. So taking it as chromium or aluminum, its solution, you will take it as add chromic acids also, add chromic acids also. Then you can the apparatus is set up for the coating of metal. So that is sorry, coating of organic compounds. So in this coating of organic compounds, here so you can start with this complete the circuit, start this increasing of this potential is volts up to the 30 volts. So increasing the volts to the 30, so make it for half an hour. So then it is after the half an hour is over, it is increased to 35 to 40 volts for 10 minutes. Then again it is increased to the 50 volts for 5 minutes. At the time there is a opaque layer. Opaque layer is a coating on the to be coated metal, that is cathode, on the steel. So that is aluminum or silver or whatever it is making as anode, that should be coating on cathode. ಹೇಳ ಅಲ್ಲ ಗೊತ್ತಲ್ವ ಈಗ್ಲೂ ಏಕ ಕೇಳಿಸ್ತಾ ಇಲ್ವಾ? ನೋಡ್ತೀನಪ್ಪ ಇನ್ನೊಂದ್ಸರಿ. ಫುಲ್ ವಾಯ್ಸ್ ಕೊಟ್ಟಿದ್ದೀನಿ ಕಣ. ಸರಿ ಸರಿ. So at the time, increase this, there is a opaque layer developed on the surface, the complete surface of the cathode. So this is, we can call it as anodizing. There is a artificial oxide layer developed on the cathode. So the developed layer is further protection to the against the corrosion. So those type of the metals we have selected for anodizing. This is the process of anodizing. So afterwards you can confirm with almost all the portions as coated with this oxide layer, then it is removed from that system, is dipped into this 100 degrees centigrades of hot water, then it is, you can dip it into this dye, that is any colors you can coat it with that. So dip it into this, its temperature also 50 degree for 20 minutes. Afterwards you can remove it, and these anodized metals you can using as any of our conveniences. So this is this, we can do it for any metals. So we can do it for any metals. So that is, we can call it as anodized methods. The process is anodizing, whether it is coating of metals or inorganic coatings. So totally it is a look like of permanent solutions. Many of the times when we this made it as a cathode, no problem, because the coating metal is anode, that should be removing, that should be suffering from corrosion, but it should not affect to the, we can call it as a basement. So this is one of the good method also. At the same way in these modern days, so we can once we can bury it, once fix into this after the ship or whatever else. So any of the portion is attacked by the corrosion, we should not remove also. It is too much of cost. It is $1 million question also, just of this corrosion control. So at the time we are doing of the one of the modern method is a cathodic protection. Means to say, make the this make the metal cathode. Means to say, you are coating of any anode metal on the surface of the to be coated metal. So on the surface of this base metal, you coating of any of the base metal, so that it look like of galvanization, so the magnesium or any of the anodic metal to that. But here we can send the reverse movement of electron. So if any of these the metal is buried under the ground due to this some of the our conveniences, but any of these anodic and cathodic areas as formed, we can find out the anodic areas. We can supply the electrons from the outer source to protect the metal against the corrosion. So from that protection is, we can call it as a cathodic protection. Against this, we can protect the metal by corrosion. Um, Modern method of supplying the electrons from outer source, we can call it as a cathodic protection. So for this cathodic protection, two examples are there. One is sacrificial anodic method, another one is impressed voltage method or impressed current methods. So first one is, we can making as same buried pipeline as considered. So wherever it is anodic and cathodic areas as formed, followed by, so from anodic to the cathodic is the flow of electron takes place. We can make it reverse, or we can fill the electrons from the outer source. With this, that anodic area is connected to the external source, that is whether it is zinc or any of the anodic metal that should be connected, we can pass the current immediately, make it reverse flow of the electron, because the we can create the one anode. So instead of this base metal, the another metal is sacrificed, another metal is suffering from corrosion instead of this. So for this word, we have suitably used the term sacrificial anodic method. So make the base metal cathode, by we can supply the electrons from the outer source in the modern technique. So this technique, we should not removing of any portion. We should not removing of any portion. So any portion is suffering from the corrosion, no need to separate. we can supplying the electrons from outer source, make the base metal cathode, that is making of reverse flow of the electrons instead of the base metal, the to be coated metal or outer source of electrons suffering from the corrosion. So far, we can call it as a sacrificial anodic method. So this is continued in that word impressed word method. Instead of that, we can supplying the electrons from the DC source. Instead of we can dip into the anode into any of these sources of aluminum or zinc or magnesium, chromium, titanium, whatever else. Anodic to the base is a metal we can remove. So directly we send the electrons from the DC current. That is, we can call it as a impressed current method. In that, supplying of the electrons from the outer source against the corrosion by the modern method, we can call it as here the anode we can add high resistance of graphite sheet. We can use some of the inert coatings of metals also we can use that time. So the supplying of the electrons from outer side where the portion is suffering from corrosion, make it fill the electrons. So instead of that, these other wherever it is the electrons are covered that coated by this anodic metal, coated by that electrons, that should be corroded, should not affect to the base metal. So far, so this type of protections, coating of metals, so coating of inorganic compound, this outer surface, the outer protection of the metal by supplying of the electron from external source. These are the three methods. All three methods are economically sound also and environmentally sound also. So once we can coat it, afterwards it is a up to certain days it should not be suffering from corrosion. So this is the module of second. So the first portion of corrosion, the second portion is metal finish. In this first portion of corrosion, the first part, two questions will appear. First one is usually the question is what is corrosion? Explain ECT. Explain ECT of electrochemical theory of corrosion. Example is iron. So after one that question, whether it is the factors or types of corrosion or anodic or cathodic protection. So the number of protections is also there asked. So you will going to explain very neatly. 7 plus 7, 14 marks you will get in the coming exam. This is a must. So you can very neatly answer into this question. So beyond these notes also, any of the books you are having, you should refer also. So totally, what are the three question papers already I sent in the group? You should answer into those questions. So that is. So next in this the third and fourth questions, the fourth questions, the part B or second part two questions are appeared, and the first questions one is appeared. First portion one question is appeared. So far you can get ready of second part also. So you are get ready of all the first part of 5 modules. 14 into 5, 70 marks you should be getting. You should be getting of 70% of 70 marks along with this one numerical, three numerical problems. So definitely you can getting more than 80 also. The 70 is of course of a minimum. So for this going to of second module, the last part is a metal finishing. So this word don't get confusion. So it's YouTube uploading also I have sent you. So you can watching of my YouTube uploading. So very neatly I can explain also. Yes, the same way I can explain here also. You have to follow this. So in that, what is this metal finishing is don't get confusion of finishing of the metal or cutting of the metal or making softness of the metals. Instead of that, whatever you have coating, whatever you have coated on the surface, that character should be made permanent. That character should be change the surface characteristic features of the metal without disturbing of its internal structures. So far, the using of the terms, a better term is metal finishing. Not get confusion of cutting or making the smooth and evenness of the surface of the metal. So instead of that, so you can the coating of metal or coating of inorganic compounds or coating of polymers or coating of any of the things on the surface of the metal in such a way change the modify not only change modify the surface characteristic features without disturbing its internal characteristics or properties. So that is we can call it as a metal finishing. Of course, we have done it in this coating of metals of galvanization, tinning, anodizing, including of this is the cathodic protections also. So here the better one to that. So we have so done everything is with calculations and designing manners. We have done calculation. Only we have consideration of corrosion. Only corrosion in the first part of the second module, but in the second part is not only corrosion. So we should make changing of all the characteristic features of surface. The coated base metal should not changing its inner characteristic. Its coating metals characteristic features completely different from all others. So in that, not only corrosion resistance, but also so it can resistance of wear and tear, resistance of impact, resistance of all these electrical and resistance to the high making hardness also. So for this, so let me can taking first point is we can go on what basis we want to this modified the surface characteristic features because of these technological importance. So it means define metal finishing. So mention the 5 to 6 um, uh, 5 to 6 technical importance means you will going to write. So what is the coating of metals or inorganic compounds or polymers or any other substances on the base metal in such a way so modify the surface characteristic feature without changing of its internal properties. This is we can call it as a metal finishing. Has same of this coating, but make coating is more permanent, more uses. Once we can coating of the metals until of its lifetime, it should not be suffering from corrosion. It should not affecting of any other problems also. The outer surfaces look like that type of metal. It is behaved. So far, we are using the metal finishing. In that metal finishing, two methods we have followed. Then one is a electroplating, another one is a electroless plating. Before going to that, so we have discussed regarding on technological importance. Those are first one is against corrosion. That is, we make it the surface is corrosion resistant. Second one is make it the surface is wear and tear resistance to provide the resistance towards of impact. In the times we can impact force is also there. It is we can using any of the times coating of this metal outer surface using in the piston and ring anywhere also we can using any time also should not wear and tear should not impact should not breaking itself we should not assessing of how it has broken that can be we can correct impact resistance. So we can fill the water in every day on the bottle. At one day itself it is for breakdown because of its impact force is not working very properly on the resistance at the time itself it is crushing or breaking. So that is impact resistance. So next is the increasing of thermal and decreasing of thermal and electrical conductivity. If it is increasing of these things, corrosion takes place. So for the conductance surface electrical and thermal conducting reduces. They provide the bright and shiny. If you want making brightness, shiny nature, reflection of light, and that shiny nature can the coating type of the metals we can do it. The next is we can import of thermal and electrical conductivities. Either we can make it more also, make it less also. So this metal is making into as a metallites like also. When the too much of temperature is there, at the time this conduction takes place. In the normal temperature 50 to 60 degree or below 50 degrees centigrade, it should not acting as a metals also because we can coating of the polymers on the surfaces. That so far the increasing of impulse of the electrical and thermal conductivity or decreasing of electrical and thermal conductivity also we can measure. As the same way, so increase the hardness. By this increase the hardness means coating of hard metal or heavy metals, automatically its surface characteristic should be changed. As the same way, this chemical resistance we can apply it anywhere also. The metal should not be corroded because of it is coated by chemical. It provides the chemical resistance, optical resistance, make it number of others, make it days, and we can make it what is etching of that, etching of the things. What we can get it as a we can bulging on the surfaces, making like walls inside also. But this impactness is hardness is including wear and tear resistance, everything should be strong compared to its basic characteristic features. So far the coating of metals, the technological importance, whatever we are having, that should be sufficiently done, that should be obeyed, that should be satisfied by these technological importance by three four types of the methodologies we have to follow. Out of that, first one is a in that electroplating is a electroplating and electroless plating. In this metal finishing, what is this electroplating? The coating of metal, same the coating of metal polymer or any of the inorganic compounds on the surface through electrolysis or by electrolysis. We can call it as a electroplating. So what is this electrolysis? The can apply the it can dissociation of the compounds into its ions through electrolysis. We can call it as electrolytes. The process is decomposition of compounds into its ions by electricity. We can call it as electrolysis. For this, of course, metal finishing requires its electricity. Without electricity, we can call it as electroless plating. With electricity, the coating of metal, we can call it as a electroplating. Electroplating, electroless plating. Electroplating means with electricity. Electroless plating is without electricity. So far, so these things have to follow. So with electricity, electroplating. Without electricity, electroless plating. So in this coating of metal, we have not followed any of the principles. We have not calculated any of these. Faraday's first law and second law, we have not calculated. So what is to be coated? That we can using of throwing put in containing bath containing preparation, we can dip it into that without dip it into also the coating of the metals using the methods. But with calculation, designings, everything we can theoretically calculate it. So we can coating more sophisticatedly by using some methods, using some principles, then it is we can call it as metal finishing. Otherwise, we can call it as metal coating. Coating is not permanent. Metal finishing is a permanent. For this, we have to follow the three principles. Three principles. Those are those principles. First one is polarization. Second one is a decomposition potential. Third one is a over voltage. So in this, what we can do it is first this polarization. So already we have discussed in the last modules of two different types of metals. We can dip it into its aerated solution due to its potential differences. So one is acted as anode and another one is acted as cathode. Wherever it is anodic reaction takes place at anode only and cathodic reaction takes place at cathode. So in this corrosion, the cathodic reaction takes place at cathode, so cathode is unaffected. Only the affection is affected by the anode. So due to this, as the electrons are moving from anode to the cathode. So there is a drift of electrons from. So that drift of electrons, you can stop it. You can make slow it. When we are using the term electrons or electrode, immediately one equation has to come, that is Nernst equation. So in this Nernst equation, E is equal to E naught plus 0.0591 divided by N into log Mn plus. You will write this so that you can calculate what is its electrode potential. So after this, you can calculate its electrode potential. So you can dip it into its solution or whatever the solution, any aerated solution. The one electron is passing from anode to the cathode. That one electron is draw from its surrounding of electron, its surrounding of anode. So that electron is supplied by its electrolyte. Electron is supplied by its electrolyte to the surface of the anode. Then that anode electron is passing from anode to the cathode. How it is so speed? So this is we can call it as unpolarized. Unpolarized. But if you make it slow, if you not supplying of the electrons from the outer surface of where the bulk region is there, bulk electrons, bulk huge number of electrons are there in the solutions, we can supply very slowly or not even send towards the surface of electrode. That is, we can call it as polarization. That is, we can catch as polarization. So slow supply of electrons from the bulk region of the solution to the surface of the electrode, we can call it as polarization. As the same way, the cathode is, we can stop to receiving of the electrode, that is also cathodic polarization. If we not supplied, anode is polarized. If we not receive the electron, cathode is also polarized. So far, this process is, we can call it as polarization. If not polarized, that is close supply of electron we have not made, immediately either corrosion takes place or using battery electrolysis takes place. The coating has taken place but not metal finishing because we have not followed the polarization of electrode. So far, polarization of electrode is depending on close supply of electrons from the bulk region of the solution, a bulk region of the electrolyte to the surface of the electrode. This is you can done so that polarization has taken place. Afterwards, the coating should be permanent, otherwise coating should be temporary. So this has to be taken place. This is the first principle, that is theoretical explanation is given to practical observation, natural observation what has happened. So that is theoretical explanation, we can call it as principle. The second principle is a decomposition potential. For example, you can take 1 meter of sleeveless wire, so you can connect it, it is this one container. So in that solution is aerated solution also there. So in that one pacemaker you will take it, so and we connect it to the battery, one is anode, another one is cathode. How it is, you can connect it for anodizing, as the same you can connect it. So from that anode one wire you will take it into this pacemaker or this counter. So it is on this sleeveless wire, you can passing of that pacemaker from the point A to B. Point A to B. If you keep the point on A, no electricity will supply. It is pass on that AB wire, pass on a little bit moving zero point 0.1 volt of electricity as passing. Look like of it's a switch. It is look like of a switch, but it is complete the circuit also. While passing on towards the B end, the electricity will supply more. The passing on towards the left, the electricity will supply less. There is no decomposition takes place. If you lesser the decomposition potential, Becerra molecular and equivalence weight, we have not calculated. We have not complete maximum supply of electricity will not supply. There is no decomposition. There is no electrolysis. So far, we can provide the electricity for continuous electrolysis of a given electrolyte, but only what is our theoretical calculation, that much of will supply, that is we can call it as decomposition potential. The electricity is required to complete decomposition of electrolyte, and that point is we can call it as a decomposition potential. It is minimum voltage is applied um, for continuous electrolysis of an electrolyte of that is we can call it as decomposition potential. For example, in that its theoretical calculation is 1.7 volt is enough to complete dissociation, complete decomposition of electrolytes into its ions. That what we can do, the pacemaker is complete the circuit. Afterwards, it is pacemaker. We can start from 1 millimeter, so zero point 0.1 volt is a volt as a passed. Continuous completely can moving on towards right hand side at 1 meter, 1 volt as a supplied. 1.1 that is meter, so 1.1 volt is supplied. Up to this 1.7 meter, 1.7 meter, the complete 1.7 volt as a supplied. Start to electrolysis, start to electrolysis, decomposition of that is disintegration of chemical energy into the electrical energy. So that is it has taken place. The coating of metal has taken place. The continuous electrolysis of an electrolyte by the minimum supply of electricity, that for that voltage supplying is we can call it for decomposition of the compounds, we call it as a decomposition potential. So that is 1.7 or 1.71 or 1.8 we can supply, its decomposition potential is 1.7 or 1.8 volt. We can neatly mention. As the same way, another one is there, over voltage. What is this over potential or over voltage? As setup is continued, you have theoretically calculated as 1.7 volt, but your pacemaker is moving towards 1.8 volt. At the time it is starting to electrolysis, starting to decompose. That point you cannot do. Theoretically calculated is 1.7 volt is required, but practically we can provide more volt to that. How much of more volt you can supply more than the theoretical calculation, that potential we can call it as over voltage. It can be denoted by this eta of practical volts minus theoretical electrode potential. So that is instead of 1.7, it requires 1.8 volts. The zero point 0.1 volt is excess. Don't you can apply the over potential or over voltage. So far the definition for this is the excess of voltage has to be provided, has to be supplied above the theoretical calculation of decomposition. We can call it as a over voltage. So it should be varied from zero point 0.1 volt onto the zero point 0.0 volt is no problem. Metal finishing or permanent coating has taken place. Otherwise, temporary coating has taken place. After few days, it is there is no technological importance. No electrical, all the resistance it has not got. It has not got. So far, at least out of the six, seven principles, at least you have to follow these three principles at the time, so you can get it as you can get this making of metal finishing. So along with this, so for this metal finishing, whether it is electroplating or electroless plating, you have to calculation of polarization, over voltage potential, and decomposition potential, and preparation of the plating bath. In this preparation of the plating bath, so you must be in this anodic. You can make anode that is anodizing, whether you can make anode or cathode. This we can make it cathode only. To be coated metal, you make it cathode only. You calculated its decomposition potential also. Along with this, you can add the lower 1 or 2 molar 3 molar of salt should be, you can add into the plating bag, not much. They were less 1 or 2 moles, you can add it based on its molecular weight. So you can add and dissolve in 1 liter of DM water. Afterwards you can add other electrolytes also, due to its increasing the conductivity under the low voltage potential. You can calculate the decomposition potential, not increasing too much to that. 1.7 is decomposition potential you can calculate. You can using the extra is volt is 1.8 or 1.9, not more to that. If it is you are using more of the electricity, so immediately, instead of metal finishing, the metal coating, that is temporary coating, has a taken place. So for other electrolytes, the complexing agents, stabilizing agents, and inorganic organic compounds also you can add it. So these are the things you can set up for the plating bath. You can prepare the plating bath, then you will select the metal, make it cathode using of there is pre-treatment also. Everything you have to do it, then it is a get ready of preparation of the plating bath, the pre-treating of the metal. So everything is all the principles you have to calculate it. So afterwards, you have to decide the coating of per centimeter square. It takes a 1 minute. So the time taken is slow. Slow coating has taken place. That is metal finishing. So very fast is there to be coated is at the time it can get it as a only the temporary coating. So far the characteristic features of good coating along with this metal finishing, there are two example. One is electroplating of chromium, another one is electroless plating of copper and nickel. So let me discuss on tomorrow, so of this electroplating of chromium and electroless plating of copper and nickel. So further, so we have for metal finishing, we have to follow the principles. I think this is easy for understanding. Its YouTube link is also there. I have already sent to your mm, uh, group. You have to watch more than one times, so you can get more understanding of my explanation along with this. Uh, Online class also you can watch it. So here only this notes is there, along with that explanation is there. In that, suppose I am using the board is also there, you can see that. So the question will come. So what is this? So what is metal finishing? Our third question is in the second question number 3. So the first part, C part, it will come. What is metal finishing and what are its types? Explain or list out the 8 to 10 technological importance. That has to be, they will ask, so you will get ready for this. So I think the third question in that second module, first question, the remaining parts are there. the coating of metals, that is chromium coating, and as well as a electrolysis plating of copper and nickel is there. So I will discuss on tomorrow. So any of the doubts you can ask me. Not now also. If you can understanding is getting problem at the time also you can call me through phone. So I will clarify your doubts. Okay. Thank you.